All right.
I tried to do something with your QDAC today. I think, but I guess I also realized that today I've got my daughter's concert, so I'll have to drop off like at half an hour's time because I have to drive like 40 minutes to get there. So I didn't realize that. So I
Oh,
was
okay.
planning, but so I'll be on the move, but I'll
All right, no
listen.
problem. But I'm gonna hit record here, guys, and so watch what you say. It's broadcasting to LinkedIn and YouTube. I should probably do something with that YouTube channel. I've actually got quite a bit of content on there now. All right, recording the cloud. Well, it's Thanksgiving, so I think a lot of our American friends are probably off doing Thanksgiving things, which I think is like watching football and eating turkey, for as far as I can tell. So, but if you are from America, happy Thanksgiving. So it's exciting day, and Black Friday, the day that retail turns profitable, I guess.
Right.
That's the it's pretty bad, right? When you have to wait until the end of November to be profitable. It's almost like working in Canada. I think the first 45 minutes of every hour you work goes to the government.
It's
So
crazy.
it's kind of like that. Which is an awful stat, I might add. 45 minutes of my life is going to pay for it. Anyway, never mind that. Martin, good to see you.
Nice to be here.
Yeah. All right. So today we were going to cover a few things. We're changing up slightly. I've got a bunch of stuff to show as well, but Rob, you want to talk a little bit about this hackathon we're trying to put together, and I've also published a new NPM that'll guide you through it. I can show people how that works. So basically, to enter the hackathon, you register in the site, but you'll also get an MCP or an MPX. You can just pop into your favorite Claude or Gemini or whatever and tell it to enter the hackathon. Um, Rob, what
Yeah,
are you saying?
yeah. Exciting stuff. I mean, there's a couple aspects that I think are really stand out about what this effort is. Um, the high level view is that the challenge around the hackathon is to reduce the amount of time that people spend searching for content. 45 minutes a day on average, which across the globe represents billions of hours. The hackathon, we don't expect over the period of the 3 days that it's formally running that we're going to end up with a finished project or a finished product. But there's sort of tiers of insights and elements that we may achieve. So it's meant to be collaborative. In other words, everybody who registers to participate is on the same team and collectively deconstruct and reconstruct this problem to see if there's some
Mhm.
innovative solutions that we can bring to this challenge. And then, it was the Paris chapter that has initiated it and brought together the support. We are partnered with TV Monde, TV Sync 5 Monde, and Google providing as a partner is providing uh, cloud services. Really nice. And then the collective team that is working on the problem will be have a portion individually, have a portion of ownership of whatever emerges and
Mhm.
evolves from the challenge. So it ends up being the concept from the Paris team, as they framed it, is a proof of concept factory, where the members of the foundation take on big challenges and look to present agentic solutions or derived solutions and participate if there is a commercial application for that, share and participate in what that looks like. And that structure ultimately will be formalized. The concept is something like a DAO, and the Paris team is working on defining that and putting that together now. So really neat for us as a community to be able to take on, some big challenges and have a formal structure there so that all the engineers who are participating have a way to participate on the upside of what potentially emerges. So that's what the whole thing is about. We're putting it together over the next week. Kaltura has stood up as a partner as well, and has been walking Mondeep, Matt, and I through the ability to do live broadcasts and rooms. So that's good. Hey, Greg, how's it going? You're hot, Mike.
Hold
Sorry,
on a sec,
man.
guys.
No, it's
I'm
okay,
gonna
buddy.
I'm gonna fix one sec, guys. I can fix one.
Yeah. And Kaltura's also set this up for
Sorry, guys. I had to mute all in order to get this particular Zoom has like this weird setting, and I haven't edited it. So anyway, I gotta look into it every week. I'm like I gotta fix the muting issue.
right.
Anyway, sorry, Rob. You
Oh,
can
that's okay. That's part of it. So Kaltura set that up, and he's also set up some demos that we can get familiar with over the next week as well, that we can
Mhm.
have our management meetings there. They automatically get recorded, and also run our Thursdays and Fridays. And they have, all the different production features are in
So
there.
we're switching from Zoom. So they kind of have their now the part that we have to figure out is how do we stream to
Yep.
like LinkedIn and YouTube
YouTube.
and wherever like we can stream all that.
Yeah,
Okay,
that's right. And then all the
perfect.
regulars, we can make everybody speakers, up to 25 speakers, and you can request to be a speaker, so you can come up, come down. Yeah, there's tons of really nice production tools that are in there, and it's really pretty straightforward once you get in. So, there'll be a bunch of us that are moderators, so we can all kinds of extra little features that we'll have access to. So really neat from Zohar. He spent a ton of time with us in setting it up. So I wanted to say a big thank you to Kaltura and
Yeah,
that team. That's
yeah,
right.
they've been there from the start, by the way. Kaltura, great, when this was like the AI hacker space back, more than a year and a half ago now. I think this was March, so we're in March coming up. That'll be 2 years. So, but I guess about a year and a half.
Right. Amazing.
Yes. Yeah, I enjoy this stuff. Like it gives me a chance to just kind of do a casual sort of conversation on what we're doing and this one, the podcast in particular is just like, hey, let's just create some crazy stuff. And if you look at the stuff we've been doing, it's every week it's like a reason to create something crazy. And so the hackathon, I think this is what we're best at. And when you look at like why do we exist and what do we do, like at least from the Agentix Foundation and this podcast and the AI hacker space, it's like what's our purpose, right? It's obviously we want to do good, we want to build for better, betterment, but there's also this kind of it's nice to build for when there's kind of a purpose in place. Like here's a target, go figure that out, right?
Mm-hmm. Yep. And just a note too, for anybody who hasn't yet and wants to participate, get more details about the hackathon as everything comes together over the next few days. It's agenix.org, and there's a hackathon registration. Sign up right there.
And there's also let me just show you guys quickly. There's an NPM because I love creating these NPMs. Let me find it. And I made this one actually when like I find it first hackathon, agentic hackathon. I made a generic. Oops. What the heck did I call it? Anyway, I'm gonna find it here one sec. Let me share my screen. All right. So I've been testing it a little bit, and so there's it's hackathon. Or let's see what I did here. The I created a repo here, a hackathon TV5, and it's an npm. So Agentix hackathon. Oh, I have an S. That's my problem. All right. I should have known better. All right, so there's a CLI. So basically, the CLI is it brings all the pieces of the hackathon together. And I thought it'd be kind of cool to do a MCP and CLI for a hackathon because I couldn't find anyone that had done that. And so why not? Let's do that. So basically, it's got all the things you expect. There's integration with different platforms and there's it you can see the status. I can add more to this as we go and like so you can kind of I think I might put in some of the like management of the hackathon itself in here. So if you want to submit that kind of thing, you go here and you do your final entry, that kind of thing. Um, Here's some settings for initialization. and there's a bunch of tools. So I've included, let's see if I can find where I'll show you what that looks like as well. I'll just run the thing. Um, one sec, guys. I'm gonna just stop sharing for a moment. Um, one of those too many windows open problems. There's a 99% chance I would show you guys by mistake one with all my environmental variables because I've been doing this long enough. You know, if there's an environmental variable available, it'll be shown. So just one sec, guys. Yeah, the while I'm loading that though, it's been a really interesting week for development though in terms of what I want. Actually, I really want to show you. I'm gonna let that load in while we're going here. But so basically, if you want to try it, all you need to do is grab this command, go into something like Claude Code Web. So you know right here I've got where did I do it? It's npx hackathon command. So in this one all I did was I went in there and said, tell me about the MPX Agentix hackathon. That's it. That was my only request, just to see how it would guide the system because I'm basically building the CLI as a kind of guide more for the AI than even for you, but you're kind of acting as the conductor a little bit here. So then I said install it. You look at the tools. It found the tools. It sees that there's Google Cloud integration. There's some of my tools. I've also included Ocean's Lion Pride, which is his new DSP. I'm not sure if he's on today or not, but that's something worth looking at. And if you guys want me to include some of your libraries, let me know. I'm more than happy to just throw those in there. Like I know Dragon's got a really cool one we could probably include, and there's several others from Mandeep and folks. So just shoot me a message, and and maybe I'll get you a few more downloads. Um, let's jump to the bottom. Let's see what we got here. Oh, it built something. It built Vibecast Pro multi-agent entertainment discovery system. Well, I guess that means it works. What the heck did it build? It built a multi-agent swarm, surprise, surprise, it's mine. Vector embeddings, also 20-dimension semantic content representation, swarm orchestrator, conversational interface. It it goes beyond keywords to understand content meaning, strong, moderate, weak confidence indicators, parallel processing, and explainable AI. Okay, you gotta do a better job. What is this in broader terms and features? Let that go for a minute. What do we got here? All right, in this case, I did, this is me just making sure everything works. Yeah, this is nothing too exciting there. Peter, but before the call started, Peter actually showed me a new bit of research. This research that came out solving a million-step LLM task with zero errors from the guys at Cognizant. And basically, so before the call started, I just pointed my latest, and I'm gonna get into that here in a minute, what my latest creation is. But basically, I said, can I use my Roo vector, which is my latest project, which is like, it's crazy. I'll go into here in a minute, and how I use it with this. So this is what it came up with. Let's see what it says here. The large language models can achieve remarkable breakthroughs in reasoning, insights, and tool use, but there's a fundamental limitation that's been hiding in plain sight. Chaining these abilities into extended processes inevitably fails. Now, keep in mind what I'm doing here is I gave it a multidimensional graph structure using hypergraphs, which is Roo vector, and I gave it a high-speed vector system to represent that in high-dimensional space, like straight up sci-fi. And then I said, go figure it out. So now it says recent experiments in the towers of Hanoi benchmark show that even the most advanced LLM become derailed after a few hundred steps. I think my reasoning and graph structures fix that, but okay. So the framework execute all. Okay, so the breakthrough maker massively decomposes agentic processes, introduces a paradigm shift, framework, blah, 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 big math. Introducing root vectors brings makers revolutionary context to practical software development. It transforms how we interact with. All right, I don't know. Like I need the problem with this is it needs to give me a more practical introduction. Then I come back to that as well. Let's see what happened here. This one is successfully created a novel hackathon entry. So what's it make? All right, so this is what it built by itself, which is interesting. I told it to just look at my MCP and CLI, and it went and actually entered the hackathon. Okay. Um, Vibecast Pro is an AI-powered entertainment discovery platform that uses multi-agent swarm architecture to solve 45-minute decision problem, the phenomenon where people waste. Okay, that's the purpose. It basically did the without. I didn't tell it to do that. I just told it to see how the system worked. Ask something, it's natural learning, semantic search, explainable AI. It's got different agents for mood, semantics, understanding emotional context, cultural relevance, personal experts, technologies, agents. Yeah, root vector. Ex so ex so that's basically how you use it. You're just gonna basically point it at this MPX, and then you're gonna come up with probably take some random paper like this one, and I'll copy that, and we'll go back here. All right, integrate the concepts of the following paper into the platform. Million steps, right? I don't know. Let's see what happens with a million steps. And ben benchmark.
You're doing that at the Root Vector platform. Is that correct?
Yeah, and I'm gonna show you guys this in a sec. And it's actually crazy. So I'm integrating. Yeah. While that happens, I'm going to jump back here for just a moment to see if we can get a better explanation of what the heck this million papers thing is. And structured summaries, key concept, executable code, working implementations. It doesn't look particularly, it didn't go particularly out there here. It's basically a multi-stepped decomposition of like a complicated series of things. Vote to catch errors. This is stuff I think we've been doing for a while, but single element call. Okay, let me jump into Root Vector. That's the really interesting project that I've been working on this week. All right. So before I start, just to summarize, there's two different approaches here you can take to language models and sort of understanding structure, right? So language models attempt to predict the next token and word, right, based on the probability of that being the right thing, and context is sort of where it is in a broader problem. So, it's useful for a lot of things, but what it doesn't do, it doesn't learn and it doesn't adapt as it does a task. So if you want to fine tune a model, your state of the art is essentially doing things like a reasoning bank and some kind of grounding system, like what I've been doing up until this point, separating the differences in logic into highly scalable and low latency requests, getting the answer and grounding the sort of response from the LLM as part of that. And that works really well. But the problem is it is difficult in terms of understanding really complicated interconnected structures. So think of like DNA or like the every individual in a city and how that and modeling every individual in a city, right? Or even more complicated things, billions and trillions of interconnected parts that are all changing and learning and adapting. So to do that, what you need two different parts of the problem, right? And the first step, which you saw a little bit last week, was the idea of a really, really fast vector system that allows you to understand, the information in a kind of mathematical format. Then the next problem was, okay, I've got this really powerful, arguably the world's most powerful vector requesting and creation system. Like it's basically just a really better version of Quadrant. And and then I included the ability to then take the cipher system from Neo4j, which essentially allows you to define how the graph works. But then I applied a hypergraph structure to it. The hypergraph structure essentially allows you to look at the information not just from 2 points, in which is most graphs do, but from many multiple different directions all at the same time. And then I used the tricks that you can use within the vector structure to optimize how you find those paths. So there's a small worlds I talk about a lot, like HNSW. This is the mechanism that's made for vector searches, but you can actually, when you combine the vector with the graph, you can use the same high-speed index as a malleable sort of learning path, right? And that is, if you again back to the sort of brain an analogy, you got a neuron, and those are bits of think of them like agents, and they do things, and then you have the synapses, which is the networks that connects those together, and those form a complex, a kind of web mesh of interconnected components. Now, what I'm able to do with that is learn based on that combination of information flowing to and from these agents or neurons, whatever you want to call them, and then have the system as it learns adapt itself. So where an LLM is static, this implementation of a graph-based neural network is constantly evolving and changing and optimizing itself as it's being used. So when you look at applications that are evolving, like again, simulations, if I want to simulate an accounting system for the next 5 years, and I want to do 1,000 variations of that, or a million or billion variations of that, I can then define all the parts of that within this structure, right? People, accounting, numbers, clients, black swan events, things that are unexpected. And then I can run these simulations over and over and over again until I get a representation of what the most probable outcome of those interconnected parts are going to be. So it's essentially creating a world model, a model that represents how it exists within the structure of the information that I'm giving it. Now, this is happening super fast. So essentially, it uses an episodic memory to handle what's happening now. And I can jump down to that section for a moment. Let me just go there. A lot of data here, but basically here's the general idea. Traditional query, a query that learns. And then I separate the information when it's learning and use a compression. This compression algorithm just came out last week, by the way. I love finding random new breakthroughs and applying them as soon as they come out. I think I applied this better than they did. But anyway, the so what this does is take hot, warm, cold, cool, cold, and archive. So when you think of the analogy of like when you dream and when you go to bed at night, you're taking what you've learned during the day, and you're basically archiving that in the different part of your brain. Different synapses and different neurons are being used, and you're compressing that information from high fidelity, like I know what he just said, I can still sort of see it. That's happening in the front part of your brain, if you will, versus what did he talk about last week, which is in your back part of your brain, a bit foggier. This is using the exact same approach, and what that does is it gives you up to like a 90 something and the 96% compression rate on all that data. So you're creating this combination of understanding, of learning, of information that can be retrieved based on certain semantic structures, and then having it actually have a sort of multi-headed attention applied to it, which gives it its own ability to reason, to have logic, to understand. Now, it isn't doing that in the way that you expect a LLM to reason and understand. Now, an LLM, again, is back to that idea of token, right? You've got a token that represents the most likely next thing. This is completely different. This is using the concepts of hyper edges and the ability to train and learn and adapt those hyper edges. So this is constantly evolving in the exact same way that your brain is constantly evolving as the information that I'm giving you is being sort of understood as you're fidgeting or doing something else. You're taking that information and then you're adjusting. You like that's what's hackening essentially in really simple terms in your brain. That same exact process is what well, I guess I've stumbled into, and the results of this thing are crazy. So the ability to do really, so I'm using fairly small dimensions because I'm running this on CPUs, and you could probably get way better and larger structures. But for the types of things I'm doing, those 384 dimensions is probably enough. But you can see here for like cosine and various things, I'm getting nanos. I'm getting sub like these are like fractions of a nanosecond to get and
I thought
traverse.
that's microsecond,
Yeah,
164 microseconds. So
yeah.
that's what's that, 1,640 nanoseconds, I believe, or maybe
Yeah,
higher,
it's
16,400.
yeah. All right, sorry, I went the wrong direction. But it's yeah, exactly. It's crazy small units of time, right? So this thing's really fast. I've made it available so you can actually use it in both your browser as a WASM. So it's going to be slower, obviously, but you can actually put all the logic and reasoning and learning directly in a browser. So you can run it on a phone, on an edge device. It sits independently of any environment, like doesn't need a GPU whatsoever. And so we've got the ability to do here vector search. You can directly use a Neo4j structure. So, you don't have to pay for the enterprise edition and it works. I ran this on, actually, I didn't run it on DNA. I was stopped from, they banned me from using, for doing DNA analysis on Claude this week. Speaking of, like, I don't know what the hell's up with that. So here, let me show you. This was working. I was doing quite a bit of DNA stuff up until this week. If anyone knows someone at Anthropic, we need to talk to them. So watch this. So if I go here, I'm gonna go to my root vector for a moment, and I'm gonna say get a public DNA data and do a deep uh, I guess analysis using root vector. That's it. That's all I'm gonna say. Nothing. I don't think there's anything too crazy here, right? So we're gonna do that, and it'll reject me. And when I use my own DNA, not my own DNA, but my own DNA data, I guess is a better way to say it rejects that too, which is really unfortunate, because so I'm working with several universities that are doing really interesting work in the combination of like sort of genetics and other things. So it's a sort of shame that they're making it difficult to sort of go through that. Yeah, it failed. Now it's just straight up failing. Before it's saying you couldn't do it. Now it just doesn't work. Yeah, they don't like that. Anyway, that sucks.
Hey,
All right,
Rick,
let's jump back. Yeah.
didn't the president literally just signed something yesterday to make a whole lot of federal data available for research just like this?
All right, let's do it.
Part of the
What?
Genesis
Fine.
program. I think.
Yeah.
Find me the link.
Yeah,
Yeah, but
eventually
not-
it's within 90 days, within
Oh,
270
okay.
days, that sort of thing. So it's not
Oh,
it's not a open the floodgates right now, but it is
Well,
it is coming.
it would
But
it
it's
would be
it's probably not for Canadians.
What kind of Canadians?
yeah. So it'd be perfect for this, right? So we've got we can do broad replication. So I built this to support the hackathon, and then that's where I started. So the original idea, where can I find that, was to handle sort of global capability. So, the ability to say, how can I build a massively scalable, low cost, super low cost learning system for 500 million users? And when I looked at like the economics of using an LLM, even if the LLM made one request to LLM provider, every hour, let's just say, I was still looking at the costs of like 30 to 40 million dollars a month. And times a year, that's basically $1 a person to operate this thing, and that was pretty crazy. So, and then I looked at, well, if we start doing this using alternate sort of graph structures, no GPU, high speed sort of vector and sort of lookups and all the things I was showing you, what would that look like? So I didn't do this, but I did a smaller model using Google's Cloud Run system, which is one of our supporters, I guess, of the upcoming hackathon. And the numbers were quite astounding. Like, and I just spun up a few availability zones, but I didn't do all 15. But I could infer the rest of the information. The cost dropped to $1.7 million a month, which is peanuts, right, for 500 million people. So massive, I think it's like 90 something percent reduction in cost. Throughput stayed the same. So basically, by using this system, if you want to build a massive global learning system that can scale and so on, this is a good architecture for doing that. And you can literally run it just on CPUs. If you add like a TPU in the mix, you could probably get even better specs as well.
And that's
So
Room Vector?
Yes, yeah, it's made up of a series. So just to show you how you pointed at it and your Claude and tell it to use the MPX and it'll guide you from there. I didn't create all the crates for the so it's built in Rust, and I've been sort of moving it from Rust into NPM using the Nappy RS ability to sort of replace the Chromium runtime for Node with your own Rust runtime. So I'm basically replacing the runtime, but I haven't done it all yet. So basically, and you can pick and choose different parts of this system. So if you're not interested, you need the core for essentially. But other than the core, you can go and you can pick and choose different things that you might want to use. So if you want to use the GNN WASM, this allows you to create a graph neural net in your browser itself. So again, basically borrow the resources from whoever's visiting your site, and then it can train and learn as those users use your website, your mobile application, or your CLI, wherever you're embedding that WASM. And again, the other benefit to this is you don't have to get all that information from your customer. So if you're in the EU and you need to abide by the EU AI Act or the GDPR, you can sidestep all the things that you can't do with GDPR because all that data never leaves their browser. So you can basically give it the algorithm that learns and adapts and gets really super efficient with what they're doing in the nature of your website without you ever seeing that data, right? Which is
So in other words,
really
it
cool.
protects the personal information, but it still has federated learning.
It's not, well, it has federated learning for you. So when you think of a multi-tenant environment, there's essentially, I don't know, 3, maybe 4 layers.
Yep.
So at the broadest layer, you've got your platform that needs to learn and it needs to adapt, but you don't, especially in a system that's learning, you don't want it to commingle your sort of client or end user data, right? And that's a separate sort of learning process. So in this scenario, for the broader system, you're going to want to sort of, remove any PII or things that might leak into other areas, but you also want the system to get smarter. So you're going to provide it that information in a way that allows it to sort of orchestrate itself better.
So I'll just give it, sorry to interrupt, Rube, but I'll just give you a top of mind use case as well for this kind of localized learning with where signals come up and you've got a federated improvement, and that's ad delivery in app optimizations. So you have personalized ad delivery in an app on your phone, but you're not moving personal information.
That's exactly you took the words out of my mouth. So there's a lot of things you're not allowed to do when it comes to, tracking and optimization because of personal data and the laws around giving away the personal data. But if this is your personal data that you are essentially controlling and giving or not giving by default the rights to, then you have the ability to use that in ways that the end user, the company powering it can't.
What are your thoughts on looking at adapting similar to feature sets that you have in computer vision? So rather than a graph flat layout, you have multi-dimensional up and down, so more of a holographic.
Yes, yeah. It's funny you also mentioned that, of course. I've been exploring holographic structures, and holographic structures are particularly well suited for the multidimensional vector and graph structure that we have here. So the hologram can be represented in, what's that, 3D, 4D space kind of thing?
Well,
And
it's similar to feature sets in computer vision, which is brain numbing trying to think about it in my bro.
yeah, so what you were doing in essence, and so the folks that are saying like LLMs are dead end. I'm now strongly in that camp. Like and if you start playing with this, you'll see why. Language is like just one part of the sort of interaction with these systems that we have. Like just your ability to read and your ability to understand what I'm saying and say things. There's a lot more happening underneath the covers than me articulating the concept. This type of AI looks and acts more like complicated networks. I'm not saying neural networks, but complicated interactive networks that need to adapt and learn are better suited for this. Now, as part of that, what I included was a semantic router that will optimize it to various endpoints. So the router itself also has a neural network applied to it. And and by the way, while I was figuring this thing out, Elton John came out and Tiny Dancer came on Spotify, so it became Tiny Dancer. But Tiny Dancer is kind of a cool little thing, and all these things can be used independently of one another. I gotta find Tiny Dancer. Here we are, Tiny Dancer Core. So what Tiny Dancer does is provides a mechanism to allocate to different AI structures independently and hyper fast as part of like a router, yeah, basically to different parts of the system. So it can do sub-millisecond, 144 nanoseconds, and so if you have a mixture of different models within the structure of the graph, so you could segment the graph to have secondary personalities, secondary neural structures in the overall graph itself. And this will then allocate to different parts, like different parts of your brain. So you could have a part of your graph devoted to the idea of visuals or the sort of three-dimensional or holographic structures that Brad was talking about. You can have another one dedicated to the orchestration of the swarm and how it builds. And all these are connected but segmented. And the system has arguably the world's fastest sort of mixture of experts gateway component that does that within the GNN itself, and this is just one little part of the overall sort of engine here that's powering this. So we've got other components here for like distributed systems. So as you guys probably have heard over the last few calls I've done, I'm excited that we've got some of these chips that are going to be coming out here in the next quarter or two. And these are chips that were designed specifically for this type of computational problem. So when you think of everything that the NVIDIA's and the sort of GPU crowd are doing, this represents everything they're not doing. This represents things that are adaptive, things that are evolving and changing and learning and moving at all times, where the GPU is like shocking with a bolt of lightning, several bolts of lightning until you're done, and then we're like, okay, we're done. No more bolts of lightning. No, we don't need any bolts of lightning here. What we're doing is saying we can solve very narrow, very powerful problems using a combination of high speed, really, 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 really fast loops of logic, and the ability to segment those for various types of sort of neural structures that are optimized for that kind of interconnected relationship. So in my core, I've got 256 cores using, it's not RISC-V either, before you ask. It's an old school ASIC, get better results from it. And that's optimized specifically for each one of these. So I've got a WASM that I can build into the chip. It doesn't give me a lot. I think it's like 100K or something. But I can take different parts of these and assemble them in different ways. So I can use a combination of the sort of direct Rust integration with the chip, and I can get orders of magnitude more performance out of these things. So just as an example of that, back to the DNA that they're not letting me do, the other day I did a DNA analysis using this, and it was actually, oh, it looks like this might be working today. I'll never, what do you know? But for the DNA analysis that I was given from the university, the DNA now, the state of the art for DNA right now is around 7 to 8 hours for a full detailed analysis. And to be honest, the idea of full detailed analysis is actually not by, I think by our standards, pretty rudimentary, but that's a separate problem. The time it took me to do 3 billion base pairs, which is 6 billion combinations, at least a minimum, and that's just two. That doesn't include all the interconnected parts of that. So to do the entire structure of the genome and put it into this graph took less than 100 milliseconds. So we're going from, and I'm like, no, this can't be true. Like this is too good to be true. It's gonna be, this is a
How
hallucination.
much
This is,
space does 3 billion base pairs take up in RAM or on disk?
well, that's where this system comes into play. I was able to compress. It was like I get the number. I can find it exactly in my stats, but it was like in the megabytes. And the reason I was able to get it so low was the compression system, which uses this new form of compression. Where is that? The tensor compress. Here, let me show you guys this.
And Ruth, how many memory do you actually need to run it?
Nothing. I was running, well, relatively speaking, I was running 32 gigs of RAM.
32 gigs. Okay, but what if you actually put it on an edge device? Would we actually be
I
able
would.
to reload it?
I don't know exactly
Okay.
Remember, I did one run. I didn't do a deep analysis. So I'm like, how fast can I actually just get all the base pairs lined up and vectorized, essentially? And the secondary problem would be, okay, now that I've got that data, what do I learn from it? Now that's where the data explodes.
Is there a verification system in this mechanism?
Yeah, there's a built-in self-verification. So the system basically it has and I can go into the anti-hallucination and some other components, but basically the system isn't prone to hallucinations because it's not based on the idea of the prediction of the next word or token. It's based on the structure of the math itself that makes up both the vector and the graph. So it doesn't hallucinate because math doesn't really hallucinate, right? So the anti-hallucination in essence is the math itself. Now, what could be mistaken potentially is the semantic similarity of things that you're trying to compare. But that's where the graph neural network comes in and helps guide it in the right direction. Okay, so one last thing here. This is the tensor compress. This came out recently, and basically this is the system that distills the knowledge, and it does a really, really good job of basically distilling, sort of, and keeping the sort of structure of the information in place. It's easier to work with than my Synthlang, but it's conceptually similar. Now, the difference is it's using dimensional. I can't. It's you guys gotta read through it. It is. I'd try to explain it, but it's like one of those moments like from Strange Mind, or what's that? Dangerous Mind. I don't know. The one where the guy sees all the calculus on the screen or whatever. One of those things. The moral of the story is it does seem to work, and this is how I've implemented the compression algorithm for the vectors. Now, why does it work? How does it work? That we might need to ask ChatGPT to give us that information. But it does seem to work really well. So if you've got a lot of data, and remember, the more you compress it, the faster you can use it, the less RAM it takes, and all that kind of stuff. So when you go back to RuveNet, you'll see compress graph network layers. It's my GNN. I think I've got. Where did I put that? I think I created a separate library. There is a separate library for it. I think I might have combined it with the GNN. Yeah, let's take a look at the GNN. Yeah, so I made, again, all the bindings for this, by the way, I've put onto on the node. Well, not all of them, actually, a lot of them. But I've put them onto Node so you can run those more easily. And to everyone, so I built Windows, Mac, Linux, and a couple different flavors of these. So let me know. I know everyone complains I don't support Macs or whatever. So this is actually built for Mac. So there's a Mac version of this as well, and you can use the WASM, I suppose. Yeah, here it is. Here, and I've been getting really good at the build system for GitHub. So you can see here, for those who are interested, I have actions. Let's see what we got here. So it's a really good CI/CD, and I'm using my Learning Bank, and I'm using the Agentic Jujitsu system, and it does all the package builds. So it basically builds the packages and deploys it. So you can see here I've got my different bindings for different environments that I've got, and that builds it in essentially a .node file. This .node file is basically a binary build for that environment, and it's essentially doing all that through these actions. Yeah, so we go, let's see here, implement placeholder. I'm not sure what this one is. Yeah, here we can see. So we can see how I built each of these. And then we can see the setup. Yeah, so if you're pushing the boundaries of how far you can take Node or npm, you're basically building in Rust at crates, and then what you're doing once you've got the crates. So you can see here that I built. Oops, I'm in the wrong one. Let's go back here. So you'll see here that I've got these crates. So these crates represent the core logic of the system. This thing's nuts. Like the fact that Claude gave me, free credits on their Claude Web was to their, I'm like that. Don't invite me to an all-you-can-eat buffet. But anyway, these are essentially all the different parts. So if you want to go to like replication, just as an example, this is the best performance you're going to get is using the crate by far. But there's about a 5% hit by moving into Node, but it's 5% when you're talking, microseconds and nanoseconds. Who cares, to be honest? So you're never gonna notice it. So you can see each of these, and then what I'm doing is I'm taking these different crates as a modular pick and play sort of approach, and then I'm bringing those as packages. So then we go here into my packages. And we see I've got some different sub packages. Actually, it's probably in source. Where the heck did I put it? npm.
Just so you know, Anthropic moved Claude Code on the web to now consume from your Claude Pro, Teams, Max, or Enterprise subscription.
Oh, okay.
So,
Which sucks. I just hit the max this morning.
I've got multiple Pro Max accounts that I switch between. So I've got one I've got dedicated to just doing code, and then I've like Claude Web Code, and then I've got another one I use for doing like VS Code. And so depending if I'm logging into VS Code, I log in with that account, and I just basically set up two different Google accounts, that I have, and I just log into one or the other depending on which one I wanted to use. It's quick and easy, but you can see here here are the packages. So these are.
What's the difference you felt while using 4.5 Opus from 4 Opus?
Say it again.
Like, what difference you felt while using 4.5 Opus? Like, what are the upgrades they made?
I've been asked that a lot this week, and I don't want to sound like I'm full of it, but I'm going to say it anyway because I am full of it. I've been pretty much at 100% SWE since July. So each time these new models come out, I'm not seeing a particular difference in my ability to create. You guys are seeing what I'm able to create. I'm able to create anything, right? That's been a solid factor for months. What changes is the timbre, the resonance, the voice of the AI, right? And what happens is I'm still able to create, but I create in different ways, and I'm guided to create different things. Like I think that the improvement for me is incremental or almost it doesn't seem that much different. I don't know, but the what that I create with it is different. So, for example, this week I built this entire root vector thing basically in a week, and I would say 60% of it is Opus 4. So it allows me to get very creative with the things I'm building. And am I guiding it or is it guiding me? I don't know. It certainly seems like the Opus 4 is guiding me a little more than the previous models. I love Gemini. The other thing I'm doing a lot of is I've been using the agentic flow system to pick and to create a ensemble of different models like Gemini 3. I think Kimi K2 is really nice model for a lot of the same reasons. And then creating a kind of council that can cooperate and collaborate on different problems. And what I'm seeing between this kind of collaboration, especially between Gemini and Gemini 3 and Opus 4.5, is they collectively empowered each other to do really interesting, novel, new things that individually I think they can do, but they kind of work together really well and kind of amplify each other's capabilities. I don't know if anyone else has tried that at all, but let's go back here for a sec. All right. Hackathon. So earlier we did a hackathon command. It looks like I've successfully integrated Maker framework from the Solving a Million. Oh, sorry, you're breaking up a little bit. Wait, what are you saying? Okay, that's README. All right, watch. So if you're working in this environment, and by the way, I created this in the Vibecast. You can see all kinds of crazy branches and things that I'm doing in Vibecast. But in this case, we're gonna go and we're just gonna go to this one. So we're gonna copy this for a sec, and then we're gonna go here, and we're going to go to the branch, I guess. And this is a nice way to sort of just quickly look at all the stuff it's built. I was totally vibing there. What's going on here? Trying to do something I didn't like. All right, so I'm gonna go to the branch. Now, if you want to explore the things that I'm exploring, whenever I just straight up vibe, I'm going to the Vibecast branches, and you'll see lots of branches. These are all Claude Code Web. So if these are just sometimes they become things. Sometimes they're just things I'm interested in, but or sometimes they're just things I'm testing. But if you're interested in what I'm working at, you kind of want to get a glimpse behind the scenes, you can take a look at these branches. All right, so this one was just created 21 minutes ago, so I'm assuming that's the right one. Vibecast, every night, 8 million, millions of people spend 45 minutes. Mood analysis, trend analysis, multi-agent discovery, agent coordination, cosmic mysteries. Rob, I don't know if Rob's still in the call or not, but it literally just did the hackathon with one command. It used my root vector. Here's an API, pro usage, multi-agent system, red flagging, anomaly detection, first head K voting. I don't even know what that even means.
So how do we make a recommendation off of it?
That's a good question. All right, let's ask.
Have you guys read the recent paper which came about cache to cache conversation between two LLMs?
Cache to cache? No, we share it.
So rather than using tokens to converse between two LLMs or two models, they have basically tried to do the conversation based on KV cache, key value cache. So rather than generating tokens, it will be communicating within itself using two models.
Like what kind of models?
So for example, there is Claude and there is Gemini. So these two models will be talking to each other using KV cache, which is the latent space where the tokens are not being generated. So it's just one step before tokens are generated.
Again,
it's more like telepathy rather than.
Yeah, it's an interesting spot. I think the issue that we face with a lot of those types of approaches is it's still sort of static, right? I think that they're just trying to optimize the reasoning process, I would guess. You know,
Yeah.
it's interesting for sure. I'm not really sure what this thing built, but it built something. That's the problem with not giving it a clear guidance. It kind of just went and built something. You know, one of those kind of blind vibing kind of experiments. But the good news is the NPM, the Agentix NPM works. So that's exciting. Yeah, any comments on GNNs? Like, I think the GNN thing is actually a really interesting approach here. It's essentially a sort of a more evolved version of my AgentDB system. Where did I put
Yeah.
that? Okay.
So does this then mean the hidden layer is now dynamic?
It's a completely dynamic. The index itself, which is essentially the synaptic network within the structure of the graph, learns, adapts, and
Because
has
one
an attention
problem I had
mechanism.
with GNNs back maybe a decade ago now was they kept growing. The hidden layer didn't have some sort of pruning mechanism.
Yeah,
Yeah, that's
I get a pruning mechanism. Well, I got several pruning mechanisms. So that's a really good comment. And the one of the reasons why I looked at compression tiers, because that essentially it takes most of the data after a certain period of time and just compresses the hell out of it.
yeah. This is
And
very similar to what I was working on. I didn't have the. I'm gonna get back to it now that you built this. So thanks, Rue. But I didn't have a good solution for the memory system that I wanted to do for a really I was making an AI panelist that would learn and be able to respond in real time. And what I wanted to do was some type of pruning slash um I would say degrading memory system so that it's not constantly looking at everything, but it's the attention is focused on current topics while other topics are getting abstracted in the background with pruning and compression and things like that you're talking about. So
yeah,
I think that this fits that really well, and I'm definitely gonna play with it.
I I I think you're right. I think, and again, a lot of the stuff I'm doing is I'm not using like traditional forms of like peer review and papers. The basis of a lot of the things that I'm building are based on this idea that does it solve the problem that I'm trying to solve reliably and and more than once, basically. And so these are being built obviously for things that I'm building as part of other projects and whatnot. So, and the answer to that is that yes, it does. It works better. My agents are better grounded. They're faster. There's lower costs associated with making LLM requests. All the things are important when you're building these things at scale. And at the end of the day, it does those things. How does the Roo vector pruning system work? This is for Jed. When multiple agents process content, you get noise, hallucinated content, overly verbose responses, malformed outliers. Pruning removes the garbage before it corrupts the downstream. So essentially, it's removing outliers and noisy signals. Back to that sort of analogy that I like to use sometimes of sort of the chaos that gets created over time. One of the benefits to highly low latency sort of systems is there's a lot less noise. The longer something exists, the more noise and the entropy and sort of chaos occurs within that bit of information. So when you're working really, really low, there's just not enough time to have that noise accumulate. So you're able, for certain types of questions, there's a lot of them, but certain types are particularly well suited to this. You can essentially create these little mini predictions, right? And then as those predictions are happening, the system is able to get a feel for, what's important and what isn't based on other criteria that's being the system based on its own attention mechanism. Attention in this case being its ability to understand itself. So in this case, the cache overtly it takes out the bad request based on time and other sort of, things like it's bad, it's too long, it's too short, whatever it is. And then this is adapting. This is always changing based on what it thinks it needs. So here's how you analyze a paper. It's going to change in the tokens. It's going to look at what's needed, what isn't. So lower, and again, self-learning. So I've embedded the learning directly in the vector and graph system itself. So everything it does, it's always just trying to learn what it needs to know. It just does that. It just magically tries to become smarter at whatever you feed it. And here's so here in this case, it's showing an example of the research paper, pruning strategies. It's like, this thing is nuts. This is like 50 different startups rolled into one. It's and this is like, oh, did you do that? Yeah, like apparently it's amazing. All right, what else we got here? Let's go back to this one. All right, this is this the one I wanted? Not sure. I had too many things going on here. No, this one's still working here. What's it trying to do here? How do I make a recommendation or get one? It's still perfect. So it's getting some errors, but that, I would guess that it'll fix itself. Your recommendation undefined. Yeah, so undefined looks like it's a problem. Unknown.
And Groove, do you have strategies for the best way to get data into this?
I've got
I know you guys are all way more advanced, but
yeah. So I essentially you're using parsers. Now I didn't bother with a whole bunch of different parsers for because you can get them from every vector vendor out there, or you can literally just ask Claude to parse it and it'll go and do that for you. Now depending on the speed and time of what you want to parse, that's going to dramatically change the experience here. I can work on your stuff in milliseconds, but you still need to parse it, and that's generally a computationally heavy activity. So parsing is going to take 4 seconds. Once it's parsed, it'll be done in 1 millisecond kind of thing.
Mm-hmm.
So the idea of pre and post becomes really important for understanding what you're going to do with that data. So when we go here back to the DNA one that we were working on, it's still working, I think. I don't know. Maybe it stopped. This is a problem also. Sometimes it just dies. I don't know why. But anyway, I like playing with this today just because. So yeah, you're essentially going to have to pre-parse and prepare your information and then train on it.
Roof, you're planning to put the vector into the Cloudflow?
I'm debating. So this is Cloudflow works really well right now, right? Okay. I'm using it right now as we speak. As soon as I use any of these, I'm just telling it to use Cloudflow for the most part, but it works particularly well in Cloud Code Web. And the database, although not particularly well suited for federation, there is a federation capability. It works pretty well using Quick and all that sort of stuff. All that kind of works, and it's and back to am I noticing any improvement in these models? No, I think I've made my own little very micro focused AGI. I can build anything. The only difference now is how long it takes me to build it and how I can and the amount of effort it takes me to guide it. So the improvements, and I'm just blabbing right now, but the improvements that we're seeing still, and this is a problem that a lot of Vibers will see, is if you don't know the right questions to ask, the system still guides you down the wrong path. Now, I have the benefit of having a constellation of random crap that I've built that I can, and I've made it even more pluggable by creating every single one of these as little modules. And all I need to do is basically say, go look at my website and go create me something that solves my customer's problem. Here are their requirements. So
correct. So that will be the standards. For example, you create these packages, which is fine, but then every time you face a product that you want to develop or an issue, then you just ask to go to your repos and see if it can find a solution or the best solution possible with all these packages. And this is the same way you're doing to increase any project that you already have. Let's say the trading system. Now you will go and tell the Claude, go to the roof vector and include this system the best way possible for the trading
Yes.
system, and that's it.
Yeah. So I'll go to neural
But how
neural
how
trader.
how you test the performance before and
Benchmark.
after?
Your bench, all the stuff, all of the things you see are heavily benchmarked. I basically don't believe anything that this stuff tells me. I think it's all full of crap
Yeah.
until I can prove otherwise. So everything you see here has been, you know, has been totally benchmarked many times. And then I have the benchmark does a couple things for me. The benchmark, one, proves that the system can work, like it doesn't throw errors, right? So by benchmarking it, I've got a way to go say benchmark every capability in the system. It could be thousands in this case of different things it needs to do, and then prove to me that the system actually works, right? And then run it over and over again. And then you can see the load testing scenarios and you know, and the criteria and the results and all that sort of stuff. And each of my crates also, at least a lot of them anyway, have also sub benchmarking components in them. You see here benches, right? So I'm benchmarking, some things don't, and then there's a dedicated benchmarking system. So the benchmarks are doing just crazy level of complex. You can see here I've rebuilt my Agentic DB system. I called it Agentic DB just to indicate that it was slightly different implementation. And so you can see here I've got different benchmarks for you know, latency, for insert updates, for more latency, memory benchmarking, comparison benchmarking, profiles. So this forms the basis of the last step of my Spark, the Spark driven development, where we have, you know, the spec, the pseudocode that drives the sort of like algorithmic part of what you're building, like what's a building basically. And then you get the architecture, how are we building it, how does it all fit together, what are the parts that makes the previous pseudocode work. Then we get refinement. The refinement is a really important step. The refinement is a feedback loop that basically says, does the thing run? Okay, it runs, or no, it doesn't run. If it doesn't run, keep trying until you've fixed and everything that you needed to do does run. And then you get the completion. The completion is this idea that you're going from a functional, optimized system at this point and looking at how it can be further improved and then prepared to be published. So in the case of a Rust project, it's creating all these bindings and Mac orientated builds or Linux or whatever, and doing all that. So by running it through the Spark specification, which is exactly what I'm doing here, I built and tested and optimized and prepared to publish. Now I'm stopping at each one of those gates. So when I'm going from spec to pseudocode, I'm reviewing that. I'm not saying go build it. Well, maybe I'm vibing and I'm just saying go build it. But if I'm building for purpose, like a customer is paying me, I'm not going to be going and saying, you know, go do everything all at once. I'm verifying that the things that I need to build or in how I need to build them are true. And for example, I always see it suggesting things like Redis. I freaking hate Redis. There's no way I'm ever going to use Redis. So I go and I check that it doesn't have Redis in it, right? Stuff like that. And then once I've given it a review, the other thing I'm also looking at really closely is the either API or SDK specification for the thing it needs to work with. And often a project I have has existing sort of integrations. Well, it has to have this voice system, or it has to integrate with this weird, you know, 30-year-old database structure or whatever. So before I start the actual the production of the system, I'm going and doing validation that those APIs actually work and I can connect with it, and the ENVs that allow me to connect with it and secrets work. And by doing that, I'm creating an entire process that I know at least that the parts that I need to interact with when it comes to data, authentication, and other third parties is functional. So that could be as simple as making sure my Supabase is set up, but it could be much more complicated than that. And that gets infused as part of the development process. So when it's doing these benchmarks, it's not just benchmarking on itself, it's using the agentic flow system, which allows it to go and gain access to OpenRouter and create agents that actually do stuff. So it's able to go and spawn additional resources from E2B if it needs more agent capabilities. So if I'm doing a lot of like data heavy analysis, which is what this is, I'm spawning up hundreds, probably thousands of E2B agents that are simulating the structure of the system in different ways, federation, multiple systems talking to each other, or different patterns. And then based on those patterns, I'm saying what's the most efficient and effective pattern I can use for various parts of the equation. So in this case, it even has a quantization mechanism that compresses it and measures the compression of memory.
So Ruth,
Like
on this point, how do you use, or do you ever use Cloudflow and Agentic Flow in tandem?
I always do.
Or
I always do.
So-
Yeah.
I mean, I hear the bit that you talked about specifications to pseudocode to architecture. I say every stage you are reviewing, but I guess in the old HiveMind or existing HiveMind or Swarm mechanism, where you say, okay, take a prime number and basically an odd number of agents, figure out how many agents you require to do that piece of work. That was the approach before Agentic Flow. I
Yeah,
guess
so-
like.
So if in agentic flow, and there's a couple things you're going to want to do. First, the most expensive, and be careful with this one. Generally, if you don't want to spend money, don't put Anthropic or Anthropic API key equals, because it'll default to that. It always wants the most expensive, most capable model, and it's built in. You're using generally, if you're launching it from Claude, it's going to want to use Claude. So be careful with that. But what you can do is use OpenRouter API key, and the system will detect that. You can use E2B API key or E2B access key, and that will allow.
Do you have any system which will verify what kind of API keys you're using? So, like on a mask, how will you verify that which kind of API keys are functional?
Well, in the case of Flow, it's going to detect that. So I built in sort of the detection of those keys. So if you tell it to, spawn a 5,000 agent swarm using remember we do this $, E2B API, E2B API key, and use Kimi. I've also got Gemini integration, so we could use Gemini 3.0 and the Gemini underscore key. Gotta hit the right button. Key. Remember when you do $, it knows that it's a system variable, and this is something someone suggested to me last week. So thank you for whoever suggested that. That was a really nice little hack that you suggested. And what this will do, this will literally spawn 5,000 using the npx agentic dash flow, and why don't we throw in Claude dash flow at, I'm gonna get rid of alpha. I think I don't need that anymore. Alpha, but init, and then we'll do force. I'm not gonna do 5,000. I'm gonna do 500 right now. And yeah, it'll take it. It'll do that whole thing, but just by asking.
How will it work? So does Agentic Flow? How does the coordination work with Agentic Flow and Cloudflow here?
Agentic Flow is the core intelligence of Cloudflow. I built it as a module because I've been moving towards that module approach. And essentially what that does is gives you the agentic agentic DB system, which includes self-learning and a lot of the same stuff in Root Vector. Root Vector is basically just a really enterprise version of agent DB. and it gives you a bunch of other things as well. So basically, it just allows it to operate separately, but it's a separate. And so Agentic DB essentially is, or sorry, Agentic Flow is essentially Claude agent SDK, and Claude Flow essentially relies on Claude Code, but can run independently of Claude Code, which is what I'm doing right now. So I'm going to use it right here to basically just manage the cluster, because it does a really good job of managing sort of complex swarms. So yeah, something like this is all you're doing. Let's see what happened here. Let's see what the DNA one. No, this one died. This happens, by the way. It's pretty beta. They call it research for this reason, I guess. So sometimes you just gotta go in there and tell it to continue. Oh, what's going on here? Thinking. Yeah, so the last thing I want to show you guys, again, you're probably curious. If you go back to my gist, you can see, you know, here are my benchmarks. Here, these are my bio benchmarks. So this is me doing a microbiome with Colby. So I did 10,000 synthetic RNA sequences, 256 dimensions. Insertion, I get 12,000 insertions a second. Dimensions, bacterial distribution. So what I'm doing in this is interesting. So what is this? What am I showing you is the question. I'm doing a RNA sampling of the microbiome, which exists within your I think it's your stomach, but basically it's your internal sort of biology, if you will, and bacteria, that sort of thing. And then I'm doing a sequence of that, and then I'm defining it using the GNN, and then I'm looking for novel sort of insights into how fast I can find things. So then I benchmarked it. So BLAST being one of the most popular sort of approaches, and that uses a lot of them use, I think it might just use Neo4j. And so I wanted to show off how much quicker I was, and the throughput is just bonkers. So I did mine in 5.4 milliseconds and 108 QPS versus their fractions of a QPS. So I'm orders of magnitude faster. And then I did the taxonomy. So some interesting things, distance calculations. This is looking at cosine simulation. So I'm distributing the information across a multi-dimensional vector. This is allowing me to sort of understand and look at information. Looks like there might be a problem there. I don't know. Memory usage. This was, I think, a question someone brought up. Like, this is 10,000. It's relatively small vector, but you can see it doesn't use really any memory. Example queries, technical implementation. The real benefit is cost. 99.998% cheaper than using BLAST infrastructure. And you can kind of tell why the universities are like, this sounds too good to be true. This is it. So you can apply this to pretty much anything that involves any kind of data where you're looking at a really fast way to do pattern matching, correlation, looking for hidden signals that are hard to see. This works on streaming data as well. So if you've got logs flowing in, don't even get me started on like hacking, or let's say securing. It's, imagine looking at every CVE there ever was in a vector database and querying it in milliseconds, and then learning and finding interconnected relation. That's actually got me thinking now. I should totally do that. Let's go do that. Do the world's fastest CVE security, the introspection and analysis system. using npx through vector. All right, so we're gonna go here. I'm gonna go to my vibe. You guys can see what happens. You can check out the branch later. I want to find and discover novel new security issues. I don't know, something like that. Yeah, that's it. That's all I'm gonna do, including using all available root vector capabilities, self-learning vector and graphs.
I think so. A couple of days before, there was some issue related to this. Claude Code was used for hacking. I read that somewhere in news.
Yes, I think that's like every Tuesday for me. But yeah, it's just we'll see what happens. I think this fits in their fair use criteria. We'll see if it shuts me down. But hacking, as you can tell, apply this to hacking, and nothing good's gonna happen. Well, I guess if you're a bad guy. But on the flip side, we can use this to protect ourselves, and that's basically what I asked. Oh, maybe not. Maybe didn't like that. We'll see this. We'll see the second go work better.
Try to convince him that it's for good reasons.
Yeah, maybe I should use
prompt injection.
Yeah. All right. So let's see here. It installs. It found my keys. Excellent. Federation supports up to 1,000 concurrent agents. It totally made that up. Why is it 1,000? Like, where did it get that from? Like, did it say here?
But these are the API keys which you have already set manually, right? Isn't there a mechanism where you can, what do you say, as this is vibe coding, the API keys are going to be randomly generated. So it's going to be difficult to authenticate and manually set all the API keys because there are multiple nested processes that you have to take care while setting up authorizing API keys.
Right. Just put them in here, and you're good to go. Just make sure you create keys that are just for the service. Don't go using keys that you might you worry about losing. Put them here and make sure you put limits on those keys. To make sure they expire, that kind of thing. But you're basically just popping them in here. Here we go. It's gonna build it. Took 2 tries, probably because it's just beta today. And it's going to build the world's fastest CVE security introspection analysis system. And I'm sure it'll be bonkers because everything this thing builds on root vector is just crazy. So we can see here.
Are you merging to main from this environment, or are you just manually going to GitHub and doing the merges there?
This is Vibecast. So for you guys, I'm not going to merge any of this stuff. This is just going to be in the.
In practice, how are you merging the Claude prefixed branches back to main?
Oh, I'm switching to VS Code and doing my final prep in VS Code. I don't generally, unless I'm just messing around. Like I built the npm for the Agentic hackathon in Claude Code. I didn't even bother opening up VS Code, but for most things, I'm switching back to VS Code and doing the final bits and pieces. And then merging. So I got builds and things, and the builds are tricky from here because it doesn't see the builds. It's using some sort of like shell script or something to interact with GitHub. So it's just rudimentary.
Roof, you are not using the Claude flow in this case, no? Directly to Claude.
Yeah. So in this case, I told it to use. You're talking in this. Told it to use root vector. No,
Yeah.
I didn't. In this one, I did.
Yeah, okay, but I mean, in this case, you didn't use Cloudflow, so it's not doing concurrently development or.
It is, and well, this one is, and you can do up to 15 agents directly in Claude Code Web. I've discovered.
How many?
15.
Okay.
And you basically tell it to spawn 15 agents, and it'll do it. Yeah, so it's building a CVE vulnerability system with GNN. I'd say that that's the first CVE GNN, at least this month for me. Right?
Try to add what do you say, a web-based UI for it. It will be easy to utilize, right?
Yeah, I'm not gonna worry about that right now. But you can dig it and build a web interface for me. Everyone always complains I don't do web interfaces. I'm I'm building this for my stuff to plug into other stuff that I've yet to build kind of approach. I don't need web interfaces. All right, I'm almost out of time, guys. Right. So
This
yeah,
stuff's amazing.
Be cool to see what you guys do with it. Thanks, Stu. Appreciate that.
Yes. Thank you very much, Ruth. It's amazing.
Yeah. Just point Claude Code at it and say, build me something bonkers with Roo Vector, and then let me know what you build. Because I think it'll be crazy.
All right. And just to let you know, I opened an issue on Roof Vector. It was very interesting. I was trying to find a solution to improve the vector communication from the edge device to like the main, like the server, and it gave me a really good idea
Okay.
based on is a new paper from Meta. It's not rack, it's a fact rack or something like that. So I use that paper and I open the issue, just take a look.
Cool.
Maybe very
Yeah,
interesting.
a lot of the stuff by the way, that I've been using is like based on Google. That reasoning bank thing, that was Google's. My integration of Quick, that's Google's. Bunch of other things. Google's on a tear. The funny thing about their papers is they crank out all these papers and they don't really give you good examples of how to use it, and it's more like brag papers. And then I take their papers and I build it.
Yeah.
So they give enough to basically quickly implement. The reasoning bank one was a particularly good one. That reasoning bank approach, I'm using that for everything now. It's kind of the basis of the AgentDB and Root Vector system you're seeing. Cool. Yeah, I'll take a look at that issue. I don't actually see it. You did it as an issue or a PR?
It's an issue. I think it was the first one of the repo.
Oh, there it is. Yeah. Oh, yeah. You're old school. 4 days. Holy moly. Okay, great. I'll take a look at that. It's a work in development. So if there's a bug, All right. Thanks everyone, and happy Thanksgiving to everyone in the US. I know you could probably be watching I don't know, football or something. But thanks for tuning in.
This is so much better. It's like a sci-fi movie.
Oh yeah,
right.
It is.
It's crazy. It is. I feel like Johnny Mnemonic. Like if I need a hoodie and like this weird, sort of cave where I have all my computers set up. But anyway, all right.